Hello everyone. On this video we will look at finding the area of a parametric curve. Okay, so to do that we just kind of jump in our time machine to Calc 2, where the formula A is equal to, from x equals A to x equals B, f of x dx is the area under a curve from A to B. And again, that's from Calc 2. Okay. So pretty much we're going to use this very same formula, but we're going to put a parametric twist to it. All right. Now, of course, for it to be parametric, we're assuming the curve is parametric. Such that x is equal to some function of t and y is equal to some function of t as t increases from alpha to some value beta. Okay, so if we decide to eliminate the parameter, remember when we solve for t for the x term and then plug it into the y term, we'll have y equals some function of x. Okay, now going from there, you're going to use the substitution rule for definite integrals. Okay, so we have our x, which we know is f of t. We have our y, which we know is g of t. And we have dx is equal to f prime of t dt. Let me clean up that x a little bit. There we go. Okay, so what does that give us? Still have our same area formula. So we have our area is equal to the absolute value, again, from x equals A to x equals B of f of x dx. And remember that f of x, or capital F of x, is equal to y. So really that's just the integral, and instead of x equals A and x equals B, we're going from alpha to beta, because we're looking at the values of t. And that's y equals, oh, not y equals dx, y dx. Okay, now since we're converting from alpha to beta, that t equals alpha, t equals beta, and y, remember that's our g of t, and our dx, remember that's f prime of t dt. So that gives us the formula we need to find our area of a parametric curve. Okay, so to simplify that out, A is equal to the absolute value from t equals alpha to t equals beta, g of t f prime of t dt, which is the same if you flipped it from some beta to alpha of g of t f prime of t dt. Okay, so this is the area with respect to x. Okay, now when you're finding the area with respect to x, the point f of alpha, g of alpha, that's the leftmost point. Or the leftmost endpoint. Okay, so that's if you're using this one here. So in other words, alpha is less than t, and that's less than whatever value beta. But if you decide to use this one, which really doesn't matter, it all depends on which value you decide to make alpha or beta. But just in case you wanted to know, this formula, f of beta and g of beta, is the leftmost endpoint. In other words, that's a beta is less than or equal to t, and that's less than or equal to alpha. Okay, so again, it really doesn't matter which one you use. It all depends on what value you assign to alpha and beta. All right. So if you are still writing, feel free to press pause, but we're going to now look at how you would approach with respect to the y-axis. Okay, which is pretty similar. All right, so what if we now eliminate the parameter where we're left with x, which is now some function of y? Okay, the reason why this formula is pretty much the same, because you go from some y equals a to y equals b of f of y respect to y. This is going to equal from alpha to beta, because now we're looking at t, x, since x is equal to f of y with respect to y. And if we work it out the same way we did the previous example, still comes out to f of t, g prime of t dt. Okay, a is equal to the absolute value from alpha to beta of f of t, g prime of t dt. But the only difference is previously alpha was the leftmost endpoint. But in this case, alpha is the lowest value. Or again, if we switch them up, it doesn't matter. Absolute value from beta to alpha, f of t, g prime of t, dt. In this case, beta is the lowest point. Uh-oh. Alright, so as long as you remember those formulas, you are all set. Alright, so let's go ahead and do a quick example. So if you're writing, feel free to press pause, but we're going to go ahead and knock out an example. Alright, so let's say, for example, we want to find the area enclosed by the curve x equals t squared minus 2t and y equals square root of t and the y-axis. Okay, now sometimes they will give you the restrictions, sometimes they won't. But what we're going to do is we're going to do a quick graph. Okay, so when x is equal to t squared minus 2t and y is equal to square root of t, let's make our t-chart. Alrighty. Okay, we have our t, we have our x, and we have our y. Okay, so for some of these, you will probably need a calculator. So when t is equal to 0, you plug that into x, you get 0. You plug that into y, you get 0. What about when t equals 0.5? You plug that into your calculator, x will equal negative 0.75, and y will equal positive 0.71. Okay, what about when t equals 1? You plug that in, you end up with x equals negative 1, and y equals 1. Okay, now if you plug in 1.5, and you get negative 0.75, and you get 1.2 for y. Move that up a little. Okay, so if you plug in 1.75, you get negative 0.4375 for x and 1.32 for y. And let's say our last point is if you decide to plug in 2. If you plug in 2 for x, you get 0, and for y, you get square root of 2. Okay, so now we have our ordered pairs, we have our x and our y. So if we decide to graph this, and our x and our y axis, our graph actually will look something like this. Where this is our 0, 0, where we're starting. Okay, so this point here is about where our t equals 0 would be. Draw a little arrow, so that's our t equals 0. Okay, so as we go up, your t equals 0.25 will be right around there. Remember, that's your negative 0.75 and your positive 0.71. And there, that's about where your t equals 0.5 would be. And your t equals 1 would be right around the end there. And you have your t equals 1.5 would be around there. That's your endpoint, your point there. And your t equals 1.75 would be around there. And your t equals 2 would be about there. And that's your 0 and square root of 2. Okay, so we're looking at the area enclosed by the curve and the y-axis. So in other words, let me take this t equals 0.5 out of here so I can shade this in. T equals 0.5. We're looking for the area right in there. Okay, so this curve and the y-axis. Okay, so that means we know we're going to go from t equals 0 to t equals 2. All right. Okay, so if we decide to look at it algebraically, we can see that x equals t squared minus 2t and y equals square root of t. Okay, so we see here intersects when t is equal to 0. But we can see that this one intersects, if you make it x equals, if you factor out the t minus 2 equals 0, intersects the y-axis when t equals 0 and t equals 2. Okay, so even if you didn't have the graph, you could have figured out that it was from t equals 0 to t equals 2 just by looking at it that way. Okay, this just gives you something to visualize as far as a picture, but this shows you how you could have figured that out even if you didn't have the graph. Okay, you still know that t is going to go from 0 to 2. All right, so that means our area is going to go using the formula from alpha to beta, or from t equals alpha to t equals beta, of f of t g prime of t dt. Which means we are looking at, we have our f of t. Actually, let me put that on the next page because I'm running out of space here. So we're going to continue that on the next page. I don't want to start cramming stuff on here. So if you are still writing, feel free to press pause. But we're going to go ahead and finish this up on the next page. Okay, so we see here, we're going from the lowest to the highest. So the lowest t value is 0, and the highest t value is 2. So we're going to go from 0 to 2. So that's going to be the integral from 0 to 2. Remember, that's t equals. We're kind of switching up a lot of variables here, so we want to keep track on exactly which variable we're going to replace. F of t, g prime of t dt. Okay, so we get a look at it. Okay, so we know that x is equal to your f of t, which is t squared minus 2t. And we know that y is equal to square root of t, which is t to the 1/2. Remember, that's also your g of t. Okay, so g prime of t is going to equal, oh, I'm running out of room there. G prime of t, that's going to be 1/2 square root of t. All right, so we go ahead and plug all of that in. We have from 0 to 2, t squared minus 2t times 1/2 square root of t dt. Okay, so that's going to equal the integral from 0 to 2. And if we go ahead and distribute that one, we end up with 1/2 t to the 3/2 minus t to the 1/2 dt. Okay. Now, whoops, forgot to close that one up. If we go ahead and integrate these, we end up with the absolute value t to the integral of t to the power of 3/2 times 1/2, we end up with 1/5 t to the 5/2 minus the integral of t to the 1/2. That's 2/3 t to the 3/2. Remember, that's going to go from t equals 0 to t equals 2. Okay, so if we plug in our t equals 2, we have 1/5 times 2 to the 5/2 power minus 2/3 times 2 to the 3/2 power. Now that would be minus the t equals 0, but that all becomes 0, so it's no point in really putting that there. Okay, which is equal to, we rewrite this. This is just square root of 2 to the 5th power. So we have square root of 2 to the 5th power over 5 times the 1/5. And this is just square root of 2 to the 3rd power, or 2 times square root of 2 to the 3rd power over 3. And I just wrote this. It's a little bit easier to work with this one. So really, if we factor out a square root of 2 from both of those, we have square root of 2 to the 5th power over 5 minus 2 square root of 2 squared over 3. Oh, this should be to the 4th power. There we go. Okay, the reason I did that is because square root of 2 times square root of 2 is just 2. And here, square root of 2 times square root of 2 is 2, but square root of 2 4 times is just 4. So it just made the math a little easier. So we have the square root of 2 times 4 over 5 minus 4 over 3. Remember, square root of 2 squared is 2. 2 times 2 is 4. Okay, so that's going to equal the absolute value of square root of 2. So if we multiply this by 3 over 3, we get 12 over 15 minus 20 over 15, which is negative 8 over 15. Which is the absolute value of 8 square root of 2, might as well put the negative there, over 15, which, because it's the absolute value, is just 8 square root of 2 over 15. Okay, so once you plug everything in, it's the same integration that you used in Calc 2. Alright, and that's it for that problem. Let's do one more example. Okay, so let's say, for example, if we wanted to find the area under the arch of the cycloid x equals r theta minus sine of theta, and y equals r 1 minus cosine of theta. Okay, so if we look at our, let's say, a quick graph of it. If we have our cycloid, and it's going to look something like that, we're just going to pick one of them. So that's when you go from 0 to 2 pi. So in other words, our theta is between 0 and 2 pi. All right. Okay, so starting off, we have our x equals r times theta minus sine of theta. So if we distribute that r, which if you wanted to, you could, you have r theta minus r sine of theta for your x. Okay, and the reason we would do that is because the derivative of x with respect to theta, we use that one, d theta is equal to r minus r cosine theta. So that means that our dx would equal r, if we want to factor that back out, 1 minus cosine theta d theta. Okay, so if we have our area, remember that's from 0 to 2 pi, but in this time it's theta, since that's our parameter. G theta f prime of theta with respect to theta. Okay, so that equals, well, we can use the absolute value symbol, but we know it's absolute value. That's the integral from 0 to 2 pi. Our g of theta, that's 1 minus cosine theta. So r, 1 minus cosine theta. Remember, that's our f of theta and our y is our g of theta. Okay, so we have r times 1 minus cosine theta times our f prime of theta. Remember, our f prime of theta is just our derivative of x. So that's also r times 1 minus cosine theta with respect to theta. Okay, so we can see here, we can go ahead and just multiply. Oh, really didn't need this extra parentheses there. Don't know why I put that. Okay, so if we go ahead and multiply our two r's, we can factor that out. Okay, so it's r squared from 0 to 2 pi. 1 minus cosine theta times 1 minus cosine theta d theta. And we can go ahead and just use the FOIL method there. So have r squared from 0 to 2 pi. And that would give us 1 minus 2 cosine theta plus cosine squared theta once we do our outer and inner d theta. Okay. Now, since we can't really integrate cosine squared theta, remember from trig that cosine squared theta is equal to 1 plus cosine 2 theta divided by 2. So we can go ahead and replace that with that. So we have r squared from 0 to 2 pi of 1 minus 2 cosine theta plus, we're just going to make that 1/2 plus 1/2 times cosine 2 pi. So we're going to break that up to two fractions. So we have 1/2 plus 1/2 cosine 2 theta. With respect to theta. Right, so really don't need that extra parenthesis. There we go. All right, so go ahead and move that up. Now we can go ahead and combine those two. So r squared from 0 to 2 pi becomes 3 over 2 minus 2 cosine theta plus our 1/2 cosine 2 theta with respect to theta. Okay, so now we can just go ahead and integrate all of those terms. R squared, getting ready to integrate it so we don't have to write that down again. So the integral of 3 over 2, that just becomes 3 over 2 theta minus the integral of that is 2 sine of theta plus the integral of cosine 2 theta is just sine 2 theta over 2, or just 1/4 sine 2 theta. And remember that is from 0 to 2 pi. Okay. So quick little side note here, that sine of 0 is equal to sine of 2 pi, which is equal to sine of 4 pi. Which is all equal to 0. Okay, so we plug in our 2 pi. We will end up with r squared. Move that up just enough. We should have room to finish it. Okay, so we have 3 over 2 times 2 pi. If we plug in the 2 pi, we end up with sine of 2 pi, which is 0. So that's minus 0. Here we end up with the sine of 4 pi, which is 0. So it's plus 0. Minus, if we plug in 0 here, we have 0, 0, and 0. So all of those just disappear. So we end up with, choose cancel out. So we have 3 pi r squared for our final solution. Okay, so really the area all depends on how large the radius is for your curve. Okay, so the larger the radius, the larger the area. All right, hopefully this made sense, and I will see you on the next video.